Hello class. Today we're on the introduction, a number trick on page 1 in our text. Think of a number from 1 to 10. Add 7 to it. Multiply the result by 2. Subtract 4. Divide by 2. Subtract the number you first thought of. Is your answer 5? Number tricks such as this have been long popular. That the final result can be known by someone who doesn't know which number was originally chosen is surprising. How does the trick work? If we make a table like the one at the top of the next page, showing what happens when it is done with each number from 1 to 10, some patterns appear. Would these patterns continue if the table were extended to include other numbers? If we began by thinking of 11, would the answer at the end still be 5? What if we began with 100? Would we get 5 at the end? If we began with 0? Do you think it is correct to assume that the trick will work for any number that you might think of? Even though you may feel that the answer to every one of these questions is yes, how the trick works is still not clear. Merely doing arithmetic with a series of different numbers cannot reveal the secret of why they lead to the same result. Now we have here our chart of numbers, and we see that each and every step is detailed on the left column, and we think of a number, and we have from 1 to 10, and we added 7, and in each column you could see the results. So when we started with 1, we added 7, we would get 8. If we started with 2, we would add 7, we get 9, and so forth all the way to number 10. Now we would multiply, and we could see that 8 became 16, 9 became 18, etc. Then we subtracted 4. When we subtract 4 from 16, we would have 12. When we subtracted it from 18, we'd have 14. So now we would divide by 2. And we divide by 2, we would have 6, 7, 8, 9, so forth. But then when we subtracted the number we first thought of, we would always end up with the number 5. Now there is a simple way, however, to discover the secret. Instead of writing down a specific number at the start, we will use a symbol to represent whatever number might be chosen, and we will begin with a box. So let's go ahead onto the board, and let's follow the number trick using a slightly different method here. Instead of using numbers, we're going to start with a box. So what is the box? Oh, I need to get my pointer here. The box represents a number, an unknown number, let's just say. So here we have a box. Now we can see from our chart that we could have chosen 1, 2, 3, 8, 9, 10, 100, 1,000, even a million, right? But we do not know what this number is, so we're going to use the symbol of a box. Throughout the trick, the box will represent the number originally chosen. The next step in the trick is to add 7. Now we will represent numbers we know with sets of circles. So 7 would look like this. So we're going to have, let's see, we have 1, 2, 3, 4, 5, 6, and we now have 7 circles. Now each circle represents 1, a whole number 1. And if we have 7 circles, well, we would have 7 here. So if we illustrate the entire trick, it looks like this. Well, we have the number first thought of. We have the box. Let's go ahead and place that box up here again. All right, and then we add 7. So what do we have? Well, we have the box plus we have 7 circles, which represents the number 7. Now, if we multiply this by 2, well, we would have to multiply the box, right, by 2. So we'd have now 2 boxes. And now we would have 7 circles. We're multiplying each of these. Excuse me, we have 7 circles we multiply by 2. We would now have 14 circles. So we're multiplying both of these. And now we have an illustration that shows what we would have done mathematically. We have 2 boxes and we have 14 circles. Now we're going to subtract 4. Well, when we subtract 4, we go to our next line. We would still have 2 boxes, would we not? Okay, because we're only subtracting 4, and we can represent that number 4 in 4 circles. So we would now, instead of having 14 boxes, we would only have 10 boxes. So we have followed the instructions up to subtracting 4. But now we're told to divide, and we're going to divide this by 2. So if we divide by 2, we're splitting it in half, let's say. So it would be like drawing a line, let's say, between the top and the bottom row here. And what would we end up with? Well, we divide the boxes by 2. We would have 1 box. And if we divided the 10 circles by 2, we would only have 5 circles left. And now we're told to subtract the original, the first number that we thought of. Well, what happens when we subtract it? Well, we would remove the box. And by removing the box, what would we end up with? Well, you know that the answer was always 5, and we see why. Because we would end up with 5 circles. Now we can go ahead and try this with many other numbers, as the chart showed us in the beginning. But by illustrating it this way, we were able to show the pattern. And regardless of whatever number we chose, we would always end up with 5 because the box represents the number that we chose. And here we had 1 box. We then added 7. We then multiplied this by 2. We ended up with 2 boxes. We then subtracted a number, which were circles only. But in the end, we divided this by 2, which put us back to the original box. And then we were told to simply subtract the box, and we ended up with 5. So it may seem, in a sense, that if you try a larger number, the numbers obviously would grow. If we looked at a chart, if we look at our chart at the top of page 2, we would see that the numbers do grow. But ultimately, the numbers that are growing are all contained within this box. These numbers would never change. Why? Well, because the instructions were to add 7, right? We would multiply by 2, which means whatever the number is here, we're multiplying by 2, but we're just multiplying over here the 7 circles by 2, and we would get 14. By subtracting 4, we would end up with 10. So we would always end up with 5, regardless of the number we chose originally. At the top of page 3, the pictures make it easy to see why, no matter what number we start with, the answer at the end of the trick is always 5. The box representing the original number disappears in the last step, leaving 5 circles. Doing arithmetic with symbols rather than specific numbers is the basis of algebra. The explanation with the boxes and circles of what is happening throughout the number trick is an example of this. One of our goals in learning algebra will be to learn how to set up and solve problems using symbols such as these.